Hello everybody, my name is Dawson Miller and today I'm going to be talking about the Unit 10 Pulmonary Exercise Physiology Part 2. Alright, to start us off, we're going to begin with ventilation. Ventilation is the movement of air between the external environment and the lungs via inhalation and exhalation. Circulation is a vital part of the O2 and CO2 gas exchange, and a little highlight of the inhalation is the diaphragm contracts, the chest cavity expands, and air enters the lungs. And then for exhalation, the diaphragm relaxes, the chest cavity decreases, and air is expelled. And I'll go over this in the next slide. I have a diagram for us. And then respiratory rate, it's important to note that it increases during exercise to meet oxygen demands. One thing to note for lung size is that size does play a factor in someone's lung size. So like usually a male versus a female will have a larger lung capacity, and this is important for things like sports and exercise. So here's the diagram that I was talking about. So on the left you can see for the inspiration that air goes through the lungs, through the thoracic, and the thoracic cavity expands, the external intercostal muscles contract, and the diaphragm contracts. And then so it widens the lungs, the air goes in simply, and then whenever you exhale, on the right, the thoracic cavity reduces, so it pushes down, the external intercostal muscles relax, and the diaphragm also relaxes, pushing that air back through. Next is blood flow in the lungs. For pulmonary circulation, we're going to talk about the pathway that it goes through. And I also have a diagram in the next slide to illustrate this. So it starts in the right ventricle, then goes through the pulmonary arteries, and then to the lungs, and then to the pulmonary veins and left atrium of the heart. The function is that it transports deoxygenated blood to lungs for oxygenation, and it returns oxygenated blood to the heart. So it's taking this blood with CO2 and other things, and it's basically cleaning it and rinsing it. And on the other side comes out oxygenated blood for the heart. Impact of exercise: increased heart rate and stroke volume, and enhanced blood flow to the lungs improves exchange efficiency. So now we have the illustration for this blood flow through the heart. And I chose this illustration because it's easy to see the deoxygenated blood versus the oxygenated blood. So it begins with the blue, and then it travels through the superior vena cava, through the right atrium, through the right ventricle, and then it comes out the pulmonary arteries on both sides, and then it goes into the lungs, and then comes back through the lungs, through the pulmonary and the veins, and that is the oxygenated blood which the heart needs, and then it comes out through the aorta. So next up we have gas diffusion. Gas diffusion is the process by which oxygen and carbon dioxide move across the alveolar membrane between the lungs and bloodstream. And Frick's law of diffusion is an important part of this. And essentially, Frick's law, it describes how substances like oxygen and carbon dioxide, they move from one place to another, and it specifically explains how they spread out and move from areas where they are more concentrated to areas where they're less concentrated. And I like to think of like perfume in a room. If someone sprays it in a corner, it's not going to be prevalent on the other side of the room, but it'll eventually start to move over there, and it travels and it spreads out to areas where it is less concentrated until it eventually fills the room. So exercise and lung function. The impact of exercise on lung function: increased ventilation, higher respiratory rate and tidal volume during physical activity, improved efficiency of oxygen intake and carbon dioxide removal, and then enhanced lung capacity. Regular exercise can increase vital capacity and overall lung function, strengthening of respiratory muscles, diaphragm, intercostals. So it's important to think of someone like a marathon runner. They have to train their body and their lungs to prepare for something like that great feat. You can't just get off the couch and go run 26 miles. You have to prep your body and do hard things, and it's just like training any other muscle. So it's important to work on it over time and just increase it. I would think of it like as a bench press. Like you're not going to be able to just go throw up a weight that you've never done before. You have to constantly work at it to increase the strength of it. So now we're going to talk about some conditions and diseases. Uh, the first one is hard for me to say. Uh, Dyspnea, I think. I don't know. But it's shortness of breath or difficulty breathing, often experienced during physical exertion or due to underlying health issues. Um, and some causes of dyspnea is um, chronic lung diseases, heart conditions, anxiety or panic disorders. And then the next is a exercise stitch, which is a sharp pain in the side during exercise, often related to diaphragm irritation. And some causes of this is poor posture or excessive movement of the diaphragm or eating too close to exercise. Um, the last is asthma. And asthma is defined as a chronic inflammatory disorder of the airways characterized by variable airway obstruction and bronchial hyperresponsiveness. Airway obstruction can lead to recurrent episodes of wheezing, breathlessness, chest tightness, and coughing, particularly at night or in the morning. Here's a quick summary of this presentation. To accomplish its functional objectives, especially during physical activity, the pulmonary system coordinates with the cardiovascular and muscular system. The lungs' respiratory zone offers a vast space for gas exchange between blood and the alveoli. The pulmonary system is less adaptable than the neuromuscular and cardiovascular system. Therefore, exercise training has little influence on it. The number of illness and ailments such as asthma and COPD can affect pulmonary function and exercise capacity.